Hello students, today we discuss the chapter number 2 press tool from the section first. Up, up till now we have studied the three chapters, that is one chapter from the section first and the two chapter from the section second. In the section first we have studied the chapter number 1, that is theory of metal cutting, and in the section second we have studied the two chapters, that is geometry and nomenclature of cutting tools, and the second one, which is important chapter, which is jigs and the fixtures. As far as our university exam is concerned, in the section first two chapters are there, that is theory of metal cutting and chapter number second, which is a press tool. And in the second section three chapters are there, that is first chapter, which is from the section second, which is geometry and nomenclature of cutting tools, then after jigs and fixture, and last one, which is economics of tooling. Then as our university exam is concerned, the compulsory question is available in the section first and another compulsory question will be available in the section second. Each question is having the 14 marks. In the section first we have to study or we have to solve the problem on the press tool or on the problem on the draw tool, and in the section second we have to solve the problem on the jig or problem on the fixture. That is the question number 2 from the section first, which is a compulsory questions, we have to solve it, and in the section second, that is question number 6, which is again a compulsory question, we have to solve it compulsory. In the section first, press tool is or to draw tool, and in the section second, jig is or to fixture. Okay, let us we see the syllabus for that particular chapter. The particular chapter is having the weightage near about 18 to 20 marks. In that 18 to 20 marks, one compulsory question will be there, which will be available on the press tool, either on press tool or draw tool. The syllabus is concerned, that is elements of press tools, types of dies, types of operation which are performing on the press, then designing. The particular chapter will be divided into two parts, that is designing of a press tool and designing of the draw tool. The particular B point which is a concern, that is designing of die for the cutting operation, mechanics of shearing, cutting force estimation, punch and die clearance, stock strip layout, design of punches and die block functioning, place of other elements, center of pressure, selection of die set and the press. This is the syllabus for the designing of a press tool. Then C point is concerned, the designing of drawing dies, determination of blank size, number of draws, stage wise component drawing, drawing radii, clearance, estimation of drawing force, time and the power. This C point is concerned about the designing of draw tool. Then and last point is concerned, that is types of bending dies and its related estimates. Okay, before going to study the press tool, we must know about the what are the different working processes will be available on the sheet metal. What is meant by sheet metal? The sheet metal is a material which are having the less thickness as compared to its wide surface area. We have to study here, that is cutting operation, bending operation, drawing, then other sheet metal forming operations, dies and the presses for the sheet metal processes, sheet metal operations not performed on the presses, and the bending of tube stock. In this chapter we have to only concentrating about the cutting operations, bending operation and the drawing operation. In the cutting operation we have to deal with a press tool design, and in the drawing operation we have to deal with a draw tool design. And the bending, in the bending we have to study the different types of bending dies. Sheet and the plate metal products, where we can use the sheet metal products at the consumers and industries, the products such as automobiles and the truck parts or its bodies, aeroplane, that is aerospace industries, whatever the body of the aeroplane or the different aerospace products, that particular body will be manufactured by the sheet metals. As we see our railway bogies, that is in the railways, cars and the locomotives, whatever our cars are available, the particular cars also, the body of that particular cars will be manufactured by using the sheet metal. Then farm and construction equipments, then small and large appliances, your office furnitures, whatever the sheet metal cupboards are there which are being manufactured by using for the office furniture. And if you are observing your computer CPU or your the particular computer appliances, the whatever the body of the computer will be manufactured, which will be manufactured by the sheet metal. Okay, these are the different applications or the consumers and the industry products which are available for which are using the sheet metal plates. What are the different advantages of the sheet metal parts? Which are having the high strength, good dimensional accuracy, good surface finish, relatively low cost, large quantities, economical mass production operations are available over there. Then sheet metal working terminologies, that is punch and die. It is tooling to perform a cutting, bending and the drawing operation. Then stamping press, a machine tool that perform most sheet metal operations. And the stamping, the sheet metal products, whatever the products will be manufactured, particular products we call as the sheet metal products. We have to concentrate about, that is concentrate about on the punch and the die operations. By that way we are performing the cutting, bending and the drawing operations. Next, that is three major categories of sheet metal processes, that is first one cutting operation, second one bending operation and the third one which is a drawing operation. In the cutting, as we know that the cutting operation will be performed, that means the sharing operation or sharing will be happen over there, and that due to the sharing, the whatever the part from the sheet metal which will be the separate out around its periphery, and to manufacture also hole in the sheet metal we are using the cutting operations. The cutting will be divided into two parts, that is blanking operation and the piercing or we call as a punching operation. Then next one which is the bending, that is straining of sheet metal around its axis. Whenever you are bend any component, suppose you are bending the rod, the whatever the outer portion of the rod will be come under the tension, and whatever the internal portion of the rod where we are bent, that particular portion will become under the compression. Okay, that is which will be happen around the your straight axis. Then drawing operation, which is nothing but a forming of sheet into a convex or concave shape. The drawing means we have to manufacture, suppose we have to manufacture a pot without cutting that particular portion, that is we are here in the drawing we are not forming or not creating a sharing action, we are creating here a forming, we are giving the shape to that particular whatever the disc will be there, whatever the large surface area will be there, and to that large surface area we are giving or we are providing one forming operation. If you are observing in the kitchen, the different types of pots are available, that particular pots are manufactured by your drawing or the forming operations. Then to perform that particular cutting, bending and the drawing operation, we have to use the different types of presses. The number one, that is according to shape, the press will be divided here, C frame, H frame. Then according to the table deposition, that is inclinable, non-inclinable, and according to stroke, that is fixed stroke and the variable stroke. These are the different types of presses. Next one, that is the press will be also type of the press according to number of slides, that is single action, double action and the triple action, and according to type of drive, that is geared, non-geared, knuckle joint, friction screw. And the very important part we have to study, or we are observing in the industries also, whenever we have visited to Anusaya press, that particular in the Anusaya press we are dealing with, that is the according to actuation, which is mechanical and the hydraulic. The next part to that particular press, that is which are the different elements are used to design any press assembly. Very important thing is that the dies and punches and their sections we are using over there. To support the punches, the punch holder will be there. To support the die holder will be there, or we call it the shoe, and the shank. To develop the assembly of die, punches, punch holder, die holder, we have to require the guide post, and along with the guide post we are using the bushings. And to lock that particular guide post with the dies, punches, punch holder and die holder, we are using the different locating and the locking component. Then to fix the feet, to fix that particular sheet metal on the die, that particular sheet metal will be fitted with the help of a stripping and the fastening component. The plate which are using over there, which is a stripping plate. Okay. Next in the next slide we will observe the assembly of the press tool. That is, these are the different elements of the press tool. If you are observing, this is a whole assembly of the press tool. We are coming from the upper side, that is this is the ram. We are applying the loads in terms of tons or in the terms of kilonewton according to the component which are using over there. That is ram, that is we called as a top plate. Then after punch holder plate, this we called as a punch holder plate. This is your punch. Then these are the guide post, that particular guide post which will be support to the upper portion, that is top plate, punch holder and the punch, and which will be contacted in the with the help of, that is die. Next one, that is next the below that, this will be your stripping plate, and this will be your die. In between the stripping plate and die, your sheet metal will be available over here. Then this will be the portion on which we are applying the punch, and after applying the punch on the particular sheet metal, your blank or whatever the component, desired shaped component will be required to us, it will be come down. Then below the die, this will be your die back plate, then bolster plate, and finally the bottom plate, or we call it as a bed of the press. Okay. Then next, in our university exam, in front of you one whole assembly of the press tool will be shown over here. You have to maintain the same sequence whatever given to you people. That is, if any of the problem will be there, you have to draw the same assembly for that particular problem, except these dimensions will be changing over there. Okay, according to dimension, according to calculation, this dimension and whatever the length, here one length will be shown over here, that is 152. That particular length may be changes over there, and the size of the punch and size of the die will be changes over there. Then but apart from that, the overall assembly and the sequence will be same as shown in front of you. That means the number one, that is top plate, then after punch holder back plate, punch holder, this will be your punch stripper plate, then after die plate, then after die back plate, and your bottom plate. And these are the two guide posts are there, and along with that the bushing will be available for the guide post. This upper portion we called as a shank, okay, which will gives the load to that particular whole assembly, and then after punch will be performed over there. Then, as I already told you, between stripper plate and your die, your sheet metal will be there, which are shown by your double hatching, and to that particular sheet metal, whenever we are applying the punch, whatever the component will be there, this component will be come out. Okay, that is in assignment second we are solving this problem. If you are observing, I was shared on your group also. These dimensions also we are calculated over there, that is top plate dimension, bottom plate dimension, then after die back plate dimension, thickness of die back plate, punch holder back plate dimensions, then after punch holder plate and your stripper plate. Okay, these are the dimensions we are calculated over there, and very important dimension, and from that dimension we are calculating this whole dimension, which is a TD, that is die plate dimension. Okay, then by that calculation the length of the particular die plate we have getting over there, that is 152. Then the how we are deciding the top plate and bottom plate thicknesses or lengths, which are we are adding here 25, that is this will be dependent on you people. You will take the 25, you will take the 20, you will take the 30. Okay, that means in short you have to draw the same assembly for the press tool. Whatever the problem will be there, only this dimension will be changing over there and this length will be changing over there, and the size of the punch and size of the die. Okay, you have to keep the, or you have to maintain the same sequence during your drawing, that is assembly of press tool, that is final assembly after solving your problem of the press tool. Then the very important thing, which is a die. Okay, if your component will be round, the type of shape of the die will be round, and your shape of the punch will be also round. If your component will be rectangular shape, that means you have to manufacture or we have to draw a component from a sheet metal, that is a rectangular piece, you have to draw over there, or blank you have to calculate, or we have to take the blank of rectangular shape. Your die size must be, or die shape must be like a rectangular shape, and your punch will be must be in a rectangular manner. Types of press operation, which are the main two types of press operation, that is cutting dies, which is nothing but your press tool design, and the second die we called as a forming or drawing dies, which is nothing but your draw tool design. Then which are the different types of dies, that is simple dies, compound dies, combination dies, progressive dies, transfer dies, and the multiple dies. We will see one by one. That is a simple die. What is meant by simple die? Here punch, die, stripper plate, and in between die and stripper plate your part will be there, or your sheet metal will be there. And what is meant by simple die? In simple die only one operation will be performed, either your blanking or your piercing, or we call it as a punching operation, perform in a one stroke and at a one stage only. Okay, that means you are applying that particular punch on the this sheet metal in a one stroke. This will be the single station and only one operation will be performed over there. This we called as a simple die. That means in a simple die only one operation performed in a one stroke and in one stage. Next one will be your compound die. What is the drawback of simple die? Only one operation will be performed over there. Suppose I want to manufacture a washer. The washer, we know the shape of the washer, that means the round disc which are having the internal holes. In that particular round disc the two operation will be performed over there, that is blanking operation, and the second one we called as a punching operation. That means first upon we have cutting that particular round disc, and in the round disc in the center we are making one hole over there. That means two operation will be performed over there. But instead of we are doing the two simple dies, we are making a die in a such a manner that that particular die we called as a compound die. On a same die we are performing two or more cutting operation, such as blanking or piercing. Piercing is nothing but punching, can be performed in a single stroke at a single station. Okay, this rod, this is your center rod. Okay, from the upper side we are applying the force. That particular center rod will be making one hole in the internal side, That means if you are observing at the bottom, this is a hole, and whatever the disc will be there, it will be cut from this side, this side. In the next slide we will see the video on that particular compound die. This is your whole assembly of a compound die. The center punch will be there, and that particular portion will cut the die, cut the blank. That is, two operation will be performed. This is by that way punching operation will perform, and this by with the help of these two parts, the your blanking operation will be performed. If you are observing the shape, okay, observe here strip. That means for C, first upon punching operation, and then after this round disc will be cut over there. That means two or more operation will be performed in a single stroke at a single station. This is a single station, only one stroke will be applied over there, and two operation will get performed over there. That is, the internal hole will be created here, and then after this round disc will be cutting over here. Okay, that means two operation that we called as a compound die. Next one will be called as a combination die. In the compound die we are manufacturing the washer. Then in the combination die, in combination die also more than one operation may be performed at a station, but it is differ from the compound die in which the cutting operation is combined with bending or drawing operation. If you are observing the shape of the punch, that particular shape of the punch which will be available in the convex manner. Okay, that means whenever we are applying the punch to that particular metal plate, this is your sheet metal, this portion and this portion will be coming to these holes which are be loaded with the spring, and whatever the part available from this line to this line, which will be take a shape like that way, that is forming operation will be performed over there, that is drawing operation will be performed over there. That means it will be seems like a inverted pot. Okay, that means inverted shape like component will be shown over there, that is draw component we have to seams over there. That means it is a differ from compound die. Why? Because in which the cutting operation is combined with the bending and the drawing operation. Next die we called as a progressive die. In compound die we have manufactured the washer on a single station on a single stroke. Two or more than two operation we are performed over there. Here in the progressive die also we are performing the same component, that is washer, which will be shown over here, but here we are using the two different station, that is station number 1 and the station number 2. That particular station number 1, that this is a metal strip and this is your stripper plate. We are inserting your metal strip from this direction. Then first upon whenever the punch will be coming down, first upon your punching operation will be performed over there. That means the hole will be created inside your metal strip. Then after that particular metal strip will be forwarded to this station, and then after whole particular punch will be coming down and your washer will be created over there. Okay, if you are observing the video you will come to know in what manner that particular progressive die will be functioning over there. First upon this punching operation will be performed, then this portion will be coming to this station, and then after whole cutting operation will be performed, and finally you will get the washer. See here, this is a punching operation, then after this will be your blanking operation. This is punching, and at that station the blanking operation will be performed. Hole will be created here, that hole will be forwarded, and then after your component will be manufactured over there. Okay, this portion and this shape is made purposefully to insert that particular part inside the punched hole. Okay, if you are observing the strip layout, first upon punching operation will be performed here, and then after drawing operation. If you are observing the whatever the stroke will be applied, which is on a single stroke, the two operation will be performed, but the difference between compound and porosity die is what? The stations are two different stations are used over here. Okay, then very important part, that is types of operation. The which are the different operations will be available during your press design or your particularly draw design. The number one operation we called as a piercing, or we called as a punching operation. Second one we called as a your blanking operation. Third one notching. Fourth one lancing. Fifth one parting off. Sixth one cut off. Then seventh one cropping operation. Eighth one perforating operation. Then after nibbling operation, lowering operation, trimming operation, and the your shaving operation. First upon, that is blanking. What is meant by blanking operation? The blanking is the cutting of a flat shape from the sheet metal. The component punched out from the sheet metal is called as a blank, and it is required product of the operation. Then in the next line we have seen over there, the hole or metal left behind is discarded as a scrap or the waste. If you are observing this diagram, this is a sheet metal, and in the sheet metal, from the sheet metal we have to require a round disc which will be our product, and whatever with the help of die and punch, whenever we are applying the punch to that particular sheet metal, the round disc will be coming out. Whatever the round disc will be coming out, that particular round disc is our product, and on the sheet metal we are left behind a hole. That means this whole part will be this sheet metal will be called as your scrap or a discarded material. I will repeat once again. Blanking is a cutting operation of flat shaped from the sheet metal. The component which is punched out, whatever the component will be punched out from the sheet metal, this will be the punched out component from the sheet metal, is called as a blank, and it is the required product of the operation. This will be the required product, and that particular product we are using for the whatever the applications will be there, we are using over there. Then in the sheet metal hole will be created, and that particular sheet metal will be used as a scrap, or it will be discarded as a waste. Then during solving of the problem, you must know the whatever the component will be given to you in the exam, which will be for you have to first upon judge which operation we have to perform on that component. Is there blanking or the punching? If it is a blanking operation, you must know the whatever the die size will be there, die size is equal to component size. That means this, if that particular disc is having the diameter of 20 mm, then the whatever the die fitted at the bottom side of that particular sheet metal, which are also having the size of 520 mm. Then what is for the punch? The punch is we are inserting from the upper side, then the punch size must be the less than your die size or the component size. That means punch size is equal to component size minus clearance. Suppose we have to clearance of 0.2 mm, then what is the component size we are considering for that particular component size of 520 mm? That is 520 mm minus your 0.2, that is that particular that is size of the punch will be the 19.8. Okay, that means for blanking you must be in a point that is die size is equal to component size, and punch size is equal to component size minus clearance. Okay, then next will be the your punching operation, or we call it as a piercing operation. It is a cutting operation by which various shaped holes are made in the sheet metal. That means in the previous slide, that particular holes are considered as a scrap, but in the punching, that particular hole are considered as your product, and whatever the metal metals are coming out from, that is whatever the metal punched out, that particular metals we called as a scrap or the discarded as a waste. That is, punching is similar to the blanking, except that in punching the hole in sheet metal is considered as your desired product and the material punched out from the hole is discarded as a scrap. Similarly here also, suppose we have to create a hole of 520 mm, so the size of the punch must be a whatever the size of the hole will be there. That means punch, for the punching, the punch size is equal to hole or component size. That means suppose the hole, we have to create a hole of 520 mm, then size of the punch must be a 520 mm. What is about die? That is, die size is equal to hole size plus clearance. Suppose you have to consider the clearance of 0.2 mm, then the hole size will be 20, that is 20 plus 0.2, that is die size will be the 20.2. okay, this is a basic difference between punching and your blanking operation. If you are observing the punching operation to the papers, you are applying the punching, okay, that is to create a hole on the papers. Whenever you are apply the punch, that particular paper that is in the round disc, it will become into the bin, that is whatever the dustbin will be there, that particular round holes will be created on the paper and the paper is considered as our product, and whatever the small pieces of the paper that is in the round manner, which will be considered as a scrap. This is the very simple operation. You have to take the difference between punching and the blanking operation. Okay, the next operation will be the notching operation. It is an operation for removing of piece of scrap from the edges. This is whole sheet metal, and from the edges you have to take the, or you have to remove the piece of the material. That particular operation we called as a notching operation. Next operation we called as a lancing operation. That is 3-side cutting and 1-side bending operation we called as a lancing operation. That is the 1 number, 2 number and the 3 number, that 3 sides we are performing the cutting operation, and at the 4th side we are performing the bending operation. That is 3-side cutting and 1-side bending operation we called as a lancing operation. Next one, that is parting off. What's meant by parting off? Cut the material between two components. Cut the material between two components to separate it from the parent metal. Suppose this is your whole sheet metal, and from the whole sheet metal you have to take that particular component or particular piece of metal outside. Whatever the material will be removed from the parent metal, that particular material will be considered as a scrap, and by applying the partition between that particular two metal, that particular operation we called as a parting off operation. That is, parting off is nothing but cut the material between two components, that's component number 1 and component number 2 will be generated over there to separate it from the parent material. Okay, whatever the material will be cut from these two components, which will be considered as a parting off. Next, that is cut off. The cutting action must be along a line. Suppose if your sheet metal is having, that particular sheet metal is not in a properly rectangular manner, and you have to cut that particular metals, or you have to cut that particular sheet metals in the rectangular manner. That particular rectangular pieces, how to cut it? That means we have cut that particular line. First upon we are taking the triangular shape of the scrap from the particular sheet metal, and then after the number 1, number 2 and number 3, whatever the component will be there, that particular rectangular pieces will be generated over there. If you are observing here in the diagram, along the line all the materials are cutting over there. Suppose the number 1 component will be manufactured over there, 2, 3, then after I will take here also, and finally here also. At last we are getting again the rectangular pieces, and that particular parts will be considered as scrap, and whatever the rectangular pieces will be there, it will be considered as your product. That means the cutting action must be along the line. The shape of the sheet metal will be in a which manner? That means if it is rectangular, if it is in a uh, parallelogram is there, or if it is a circular, if you have to cut that particular material in along the line, that particular cutoff operation will be used over here. Next, cropping, the cutting operation to control the strip movement. If the particular sheet metal is having the wide surface area, this is the length of the sheet and this is the width, okay, and if you have to fix that particular sheet metal below the punch and above the die, then to restrict the movement of that particular sheet metal, we have to cut the sheet metal in such a manner that the particular sheet metal will be stuck due to that particular cropping operation. Whenever we are forwarding that particular sheet metal, that is it's a feed direction, and we have to perform the operation only that particular part, okay, that means we have to make a minimum scrap over there, okay. At that time, what is performing over there, what is doing over there, we are cutting the sheet metal in such a fashion that that particular sheet metal will be stuck due to that particular cropping operation. That means the oil pin is fitting over here and here, and that's why the its a feed movement will be restricted over there, and we are performing whatever your operation will be there. It may be a punching or it may be a drawing operation, we are doing in a proper manner. That means the cropping we are doing for the cropping operation, we are doing for the cutting operation, that is cropping is a cutting operation to control the strip movement of that particular sheet metal. Next, that is perforating. Maximum number of holes are pierced in a single stroke, that is maximum number of holes are pierced or punched in a single stroke. If you are observing the holes of equal dimension, suppose the 5 mm holes are there, that particular 5 mm holes are generated or punched out by using a single stroke. That particular operation we called as a perforating, that is maximum number of holes are pierced in a single stroke, that particular operation we called as a perforating. Then after nibbling, to cut out the sheet to size with the help of punching operation. Suppose this is one sheet metal and we have to cut that particular sheet metal from the middle or from the any of its side. Then to separate out that particular sheet metal, we are punching in along that particular line in such a manner that the first punched hole will be nearer to the second one, will be nearer to the third, fourth, fifth, sixth, and in that fashion, by using the number of punching operation, we are separating out that particular two metal strips or two sheet metals, that is to cut out the sheet metal to the size with the help of number of punching operations, that we called as a nibbling, which is nothing but the nibbling. Next one will be our lowering operation. As we see the lancing, what we did in the lancing, 3 side cutting and 1 side bending operation we called as a lancing. Similarly here also, lowering means the 3 side forming and 1 side cutting operation is nothing but we called as a lowering operation. That means number 1, number 2 and number 3, and that particular 3 side we are performing the forming operation, and at the another side, that is at the 4th side, we are performing the cutting operation. That particular operation we called as a lowering operation. Then next one will be the trimming. If you are observing this component, this is your drawing component, as we have studied, that is cutting, bending and the forming. This we called as a forming or the drawing operation. That is, if we are not cutting that particular component, we are giving only shape, okay, to that particular component. Here, after the drawing or the forming operation, whatever at its periphery, whatever the metal will be left here, that particular metal will be, we have to trimmed out, and that particular operation we called as a trimming operation. That is to cut the excess material which is left out on the flange of a draw component. This is a flange of the draw component or formed component, and whatever the excess material will be there, that particular excess material will be trimmed out and it will be considered as a scrap. That process we called as a trimming process. Next, we call it as a shaving process. After blanking or the piercing operation, we have to give the finishing to that particular blanked hole or the pierced blanked component or to the pierced surfaces to give the finish cut to that blank or the pierced hole, which called as a shaving operation. That is small piece of cut which will be taken out, and that particular operation we called as a shaving operation. Okay, thank you. The whatever the next portion will be there, we will study in the next topic. Okay, thank you.